Over the last several years, there has been an increased interest in trying to make haylage as a stored feed to be able to feed during the wintertime for livestock operations. And there's several different names for kind of the same package. I mean, it can be called hay crop silage, hay crop, baleage, round bale silage. All of them are kind of the same. They're talking about the same thing, just different names. And really what we're talking about doing there is taking a forage crop and basically baling a wet forage crop and then wrapping it in some sort of plastic. So it could be an individual bale wrapper where it's wrapped in plastic, and basically when it's in the field it looks like a bunch of marshmallows sitting out there. Or it could be using these inline wrappers where you make this big long tube of round bales stacked one next to each other and they're all wrapped. But the process of making haylage is pretty straightforward. There's just a few things you really have to pay attention to and understand. The first thing that you have to understand is the moisture content. Okay, so most forage crops standing out in the field, green and growing, are going to be somewhere, 80 to 85% water, and that's their percent moisture. And so a lot of times if you're trying to make haylage, make this round bale haylage, what you need to do is you need to be shooting for 50% moisture. So you need to get it dried down. And really, if you're shooting for 50, but you can be 10% on either side of that. It can be anywhere between 60 and 40% and still get good fermentation. Because what's going to happen is you take and you bale it at this moisture and then you wrap it. So once it's wrapped, there's no more oxygen that can get into that bale. So once it gets wrapped for the first 2 to 3 days, something like that, the oxygen that was trapped inside that gets used up. And then we have what we call an anaerobic environment, meaning no oxygen is present. So what happens then is the bacteria that can grow without oxygen begin to kind of grow and proliferate. And the main one of those are in the genus Lactobacillus, because what those bacteria do is they take carbohydrates, the sugars inside that crop, and one of their byproducts is lactic acid, which drops the pH. And so then over the course of the next 3 to 4 weeks, something like that, you just get this process going on. You get more and more lactic acid made that drops the pH. And usually with, these hay crop silages or this baleage, usually your pH is going to get down into the low fives. And then pretty much at that point, fermentation stops, and then it's a stable package that you feed, during the wintertime. But that acidity that you get because of lactic acid is what makes it stable. Well, first thing to understand is you've got to get that moisture right. If you bale it too wet, then you probably won't be able to make enough lactic acid to be able to get the pH dropped, and you can get some really, weird stuff going on. You can get, instead of getting lactic acid, you can get something called butyric acid mage, which just smells horrible and is totally unpalatable, so it'll be wasted. So if it's too wet, you have a problem. Also, if it's too dry, you can have a problem that there's not enough moisture to get the good fermentation. So you're shooting for that between 40 and 60% moisture is what you're shooting for. That's the first thing to understand. The second thing to understand is you have to make sure that you keep it airtight. So the point with these wrappers and putting this plastic on it is to keep the oxygen out. So you want to make sure that you put, you probably want to put between 4 and 6 layers of plastic as you're wrapping it to make sure that you make it airtight, because if it's not airtight and there's oxygen that still gets through, say that you don't put enough plastic on, or let's say during the process you get some holes in it so that oxygen can get into those holes, then you won't have a good anaerobic conditions, and so you really won't get good fermentation because there's oxygen that's still in there. So that's the second thing to understand. Really, the third thing to make sure you understand is that making haylage does not improve the quality. If I have, some sort of a grass crop and I cut it, instead of cutting it the first week of May, I wait and cut it the first week of July, and it's stemmy and got a bunch of seed heads on it. If I cut it and try to make haylage out of that, it's not going to improve the protein content. It's not going to improve, the energy content. It might make it slightly more palatable because a lot of times livestock really like that, that fermentation smell and that taste and everything, but it's not going to improve the nutrient content. So really, you still got to make sure that you cut it, in a timely fashion to get as much protein and energy out of that crop as you can. Probably the biggest advantage of making haylage is that, with hay, I've got to go from, 80% moisture down to basically below 18. And so that takes, depending on the weather and everything, it could take me 4, 5, 6 days for that to happen. Whereas with haylage, I just have to go from about, 80 down to 50. Well, a lot of times, I can cut one day and bale the next. So I don't need as long of a rain-free window, which that's a real issue sometimes in the springtime, is getting enough days without rain that I can make a good, crop out of that. So that's the real advantage that haylage gives me, is that I usually can get in a field, cut it in a more timely manner because I don't need as much dry weather to get that done. So that's just a couple of things to understand about haylage. Pay attention to the timing of your cutting. Get it cut early so it's a high quality crop. Make sure you get it baled at the right moisture, shooting for 50%. And then the third thing is making sure that you get it wrapped airtight and you keep it wrapped airtight. So if you get a hole, put some duct tape on it because you want to keep that oxygen out of that package.